Good morning. Thank you for joining us today for Evolving IT Infrastructure, the Future of Flash Storage in the Software-Defined Data Center, presented by Forrester and Pivot 3. My name is Stacy, and I'll be your moderator today. I'd like to cover just a few housekeeping items before we get started. This webinar will be recorded and posted on the Pivot 3 website under the Resources tab. We'll also email a link to the recording and the slide deck after the event. If you have any questions during the presentation, please type them into the question box. We'll be addressing your questions at the end of the webinar. Now it's my pleasure to introduce you to today's speakers. Richard Fichera is Vice President and Principal Analyst for Forrester Research, serving infrastructure and operations professionals. He has coverage responsibilities for servers and data center architecture and transformation. Among the core technologies he focuses on are blade and modular servers, converged infrastructure, virtualization and management of virtual data center resources, enterprise cloud infrastructure, and techniques for data center transformation. We are also joined today by George Wagner, Senior Manager of Product Marketing for Pivot 3. George focuses on hyperconverged and flash storage solutions. His career in information technology began in IT administration before transitioning into technical sales and ultimately product marketing for shared storage. George's career spans several technology startups as well as traditional IT companies like Hewlett-Packard. George uses his experience as an end user of IT to communicate solutions to today's IT challenges. And so without further ado, I'll pass things over to Rich to kick us off.
Thank you, and good morning or good afternoon to everybody out there. Today we are going to, if I can get the screen to respond, we are going to be talking about some of the key trends in infrastructure and particularly storage that we're seeing here at Forrester. And as you heard, I'm Vice President and Principal Analyst here at Forrester, and on a routine basis, I get a lot of inquiries from clients on storage and storage strategy, storage technology, the vendor environment, and these interactions range from half-hour inquiries to multi-day consulting engagements. So it's a thing that we are able to sort of see longitudinally, and a lot of our insights are derived from this constant contact with enterprise clients. So what I want to talk today about, start with something that you've probably been exposed to, but I just want to highlight again, is the complexity and scale that we're dealing with, along with the changes in the underlying architectural model. Now, you've certainly seen this curve. You see it everywhere you look, an exponential growth curve. We've been living with it for decades, but the sheer magnitude has sort of started to bite us in the last few years. And this is associated with basically every metric associated with our distributed environments today. You know, servers, internet users, numbers of people, numbers of devices, amount of storage, numbers of transactions. You know, and we tend to focus on this, but the volume is not new. The number of decimal places is new, but it's more than just a volume effect. It's affecting our ability to deal with this change, and from an infrastructure perspective, our ability to remain sufficiently agile to keep up with what the lines of business want. It's also the underlying complexity, the fact that the relationship between these actors has changed over time. So the complexity axis is orthogonal to the volume, the number of users, and the size of the data objects. It's a whole new level of complexity, and this changes how we have to engineer our infrastructure. The biggest change, this growth and the relationship between them, is totally changing the way we have to engineer our infrastructure resources and to think about them. The old view was that you had pretty stable relationships between the infrastructure elements. What we're dealing with now is that the volumes and complex service architectures are making the matching of resources increasingly a challenge. We're storing more data. The performance requirements continue to escalate, and the ratios of storage to compute are variable. So it's really difficult to come up with a one-size-fits-all model anymore. And the biggest shift is kind of a mental shift in perspective, at the enterprise management level, is infrastructure is now a strategic asset. It's not a cost center. And maybe because my business involves looking at infrastructure constantly, I think it's a differentiator, and companies who do it right can build and sustain advantages over people that don't do it right. Probably the most dramatic place we see it is in storage. If you think about the legacy relationship of storage to processing, and this, my memories of this date back a long, long way, it was a relatively static, linear relationship. A server was connected with storage, transactional, data was read, transactions were executed, and data was written back to persistent storage. What's happened as we've gone into this era of, the web, mobile devices, increasing use of private, public, and hybrid cloud, different kinds of services hosted in different environments, is that the data movement and data storage requirements have become incredibly complex, and the storage is no longer static. Data comes in from one source. It can be transcoded, reformatted, extracted, archival copies made, snapshot copies made, business continuity volumes. You can extract pieces and send it off to analytics. You can send some out to be processed by other applications in the cloud. The data may be subsequently brought back. So it's more like a railroad switching yard than it is the legacy view of storage, and that's dramatically complicated the way we build our storage architectures. If we look, for example, it's easy to say you need to make your storage, more responsive, more cost-effective, more unified. But when you look at the underlying requirements, you see that there's considerable diversity, considerable architectural diversity in the requirements. I took 5 sample workloads here and mapped them out against 5 major resource requirements: CPU, memory, amount of storage, network throughput, network latency. And as you can see, these are very different shapes. So the implication here is you have to start thinking carefully about how you build your infrastructure and what kinds of storage you deploy where. This is a common theme through this presentation, is that the one-size-fits-all mentality isn't right for today's world. You can come up with a kind of a middle solution where one size fits a lot of stuff, but it's really difficult to get the really critical corner cases all in the same infrastructure technology and architecture. And increasingly, we have to look at this as a holistic integrated design problem, because we have to look at the processing requirements versus the storage requirements and the network, because throughput and latency are strongly linked to the network characteristics in some environments. And over time, we can clearly see that the new problems spawn new approaches to these, to these various successive bottlenecks. If we go back looking at core transactional processing, we had successive generations of increasingly optimized fiber channel arrays. We added enterprise NAS to this when it became apparent that there was a lot of unstructured data and a lot of file structured data that could be better addressed than through block mode access over fiber channel. Then we started adding iSCSI for the ability to do block over the same Ethernet that was connected to NAS. Then people started looking at scale out NAS and object-based storage as solutions to the incredible proliferation not only of data volume, but in terms of number of data objects as we increasingly get into highly distributed environments that spin off tons of data that we may want to apply analysis to later. And this will become even more pronounced as we move into the Internet of Things. Then we started to look at raw performance. Flash has been with us a long time. Flash and even RAM disk has been with us a long time. But costs in the last few years have started to come down to earth, and now we're seeing a huge surge in interest in and affordability of all flash storage, and it's starting to replace both the performance disk tier as well as working its way down in the second tier storage. And then as an overlay to several of these technologies, we see the development of software-defined storage. And the intersection of flash arrays and software-defined storage is going to be a powerful trend that shapes the way we think about storage infrastructure going forward. Up until now, the storage has been dominated by hardware-defined platforms, and you will see this as a not particularly clever allusion to the concept of silos. And this has been the way we've worked. You've had core, high-performance transactional arrays. You've had NAS systems. You've had separate systems for backup and deduplication backup. And these worked. The vendors who supplied those and the users who used them applied them very productively to their problems, but it's not a sustainable model going forward. We need to look for more integration. Some of that will happen by default as tiers, I'll talk more about this later, as tiers collapse behind affordable flash. But this is not a sustainable model for the future. And when I talk to users about what they're doing to optimize their storage investments, there are three things that continually come up in discussions. Software-defined storage as a way to break down previously hardware-defined silos. Also because it implies API-based access, and generally includes, and not exclusively to software-defined storage, generally includes the notion of QoS, which is another critical ingredient for forward-looking storage architectures. Another trend, and these are somewhat linked, is object storage. Scalable NAS and scalable object stores. There's a tremendous amount of activity in the industry and interest on the part of users for highly scalable object storage, and increasingly the ability to geographically distribute the object storage and have the object storage management take care of things like synchronization of enterprise versus remote office data and consistency and so on. So this, and increasingly these are heavily software defined, and it's not uncommon to see these software platforms layered on commodity servers. The other key trend is flash, and the precipitous decline in flash and the proliferation of available flash technology on the market has really been pushing flash to the forefront. As I said earlier, it's capable now of replacing not only the tier 1, the performance tier, but what previously people used to think of as tier 2 storage. It's still important, but it's not quite as fast, or critical as tier 1. It's got a lot of other benefits as well, particularly around not only around performance, but around reduced potential licensing costs and OpEx, and I'll talk more about that later. But these three right now are kind of the holy trinity for when I talk to people about storage. This is probably most of the inquiries that we get about storage. Flash is an interesting subject because depending on how long you've been looking at it, you may have some misconceptions about it. One of the prevalent myths is it's too expensive. And the reality is that flash prices are rapidly declining. And when you consider the fact that most flash storage has effective deduplication and compression, and they're increasingly implementing advanced technologies like erasure coding and advanced RAID architectures to make to not only provide data protection and faster recovery, but also reduce the overhead implied with that. We're seeing effective capacity prices now passing well below $2. We're hearing vendors tell us they're targeting $1.50, and whenever they tell us numbers like this, they're being inherently conservative, because I know from end users that I talk with that there's tremendous discounting pressure in the industry. I expect by the end of this year the publicly visible price per effective gigabyte net of compression and dedupe will be under $1, and I think the street price will be under 50 cents. and we're going to see flash-based object stores where the vendor described pricing will be in the neighborhood of 50 cents a gigabyte. So the prices are coming down. Another myth is that flash is unreliable, especially you'll hear what people refer to as consumer-grade, low-cost flash. The difference between a consumer-grade and enterprise-grade flash media was important a few years ago when people were selling discrete SSDs, and in fact still is, in that a discrete SSD does not have as sophisticated front-end software. But now the reality is vendors are guaranteeing flash media in their storage systems for up to 7 years, and particularly the flash management, the flash physics, as some of the vendors call it, parts of the software to increase the endurance have become so sophisticated that as a consumer, as a user, you don't need to worry about the choice of the media. You know, you look at the vendor's guarantee, the vendor's warranty, and that tells you all you need. And this is a continual competitive playoff. So there's going to continue to be a lot of investment into that. But you can basically at this point, flash carries longer media guarantees than your disks. Another is capacity. Another myth is capacity. That capacities are limited. They're not very dense. There's been a huge sea change in the last 3 years in how people package flash and the density. You are now looking at petabyte range per rack. 1 to 2 petabytes per rack at least, and that will get denser this year as people introduce some subsequent products. So you can get petabyte scale, petabyte per rack scale, and prices under a dollar an effective gigabyte. This effectively is competitive with performance tier disk without any doubt, and the real street prices after heavy discounting in competitive environments are probably going to be even better. So these 3 myths, as the TV show would like to say, these are busted. And there's a lot of innovation going on in the flash world, which is going to continue to drive down prices. The media changes have been occurring pretty rapidly. We've gone from single-level cells to now we have 48-layer 3D NAND chips. And we went from 32 to 48-layer production chips in less than 6 months. The write endurance has improved at all levels, both on chip and the embedded controller level and at the storage array controller level. And we have no worry at a macro level in the industry. The flash capacity coming online in the next 18 months, depending on whose forecast is another 40 to 50% of capacity. This ensures a very competitive industry and an ample supply. I think that the risks of transient price spikes are low, and most importantly, it's not an oligopoly situation. We have 3-4 major vendors that are intensely competitive with each other, and they are going to be at each other's throats for years on price. And there's ample headroom in the process roadmap to make this flash denser and cheaper. So you've got at least 4 global suppliers intensely competitive and a lot more capacity. So no risk of shortage there. And finally, the features in the arrays are rapidly maturing. It used to be very easy to tell the difference between an enterprise tier 1 array and a mid-range array. It's getting increasingly difficult now. There's huge overlap. Things like dedupe, compression, thin provisioning, snapshots, clones, those are pretty much jacks or better nowadays. And as I said, the price is going way down. Also, and this is particularly important, flash is more than just performance and cost per media. Flash is positioning us to eliminate a lot of tiers of storage, which is going to get very important as we want online access to a lot of data for analytics that we can't put out to deep archiving. You don't need to worry about performance tiering, optimization of tiering that you do either manually or automatically in some hybrid products, because The performance of the flash media is location independent, which takes a huge burden off a lot of complex software. And the media performance is relatively flat. There's no penalty for near far access, and there's not a lot of difference across the vendors. So it's a pretty flat landscape. And when you add quality of service capabilities, you can allow. That's where you can differentiate between what used to be different tiers of storage, different classes of storage. You can specify the levels of service you're willing to guarantee. And increasingly, as we look at applications, anything involving analytics and customer-facing applications that generate a ton of small metadata objects, you can't predict which pieces you're going to need for future analytics. Keeping it on low-cost flash means that these applications have got access to this data without extensive media migration, which is always this kind of hidden burden in managing complex storage environments. And we're seeing this evolution in storage tiering as well. I talked to a client last year who had 7 storage tiers, 7 storage classes, and they were quite proud of it, but it was amazingly expensive to manage. I think really most enterprises are heading toward a performance tier, a cost-efficient tier, and maybe a deep archival or backup tier. But the days of 4, 5, 6, 7 classes of service, 7 classes of tiering are gone. And we need that for the kind of fluid access to enterprise data that we're going to require. So let me talk a little bit about some disruptive megatrends, some sort of things that are happening in the future. First of all, we've got the software-defined storage and flash. I think are going to transform both the physical side and the operational side of storage. Coming behind flash, we have a whole wave of new non-volatile memory technology. There's multiple horses in this race, and all of the major flash vendors have got programs with alliances going on here. There's conductive bridging RAM. There's other kinds of resistive RAM. There's phase change RAM, which is probably what 3D XPoint is, although Intel and Micron won't confirm that. There's even a company making carbon nanotube RAM, which is, I think, my personal favorite for sort of like interesting and quirky and exciting. The first wave is going to be simply flash in DIMM chips. This has been on the market as addressable as storage with limited appeal. You've already got one major vendor, HP, that's announced flashback DIMMs as a standard product and is working with ISVs so the software recognizes that. You will start to see flash appear. A company called Memory One is going to be introducing flash in the system address space addressed as DIMM, which will vastly expand the available memory space for things like in-memory analytics. The second wave is going to be, you're going to see these things, rather that's the second wave, excuse me, is using these as expanded DRAM space. And you'll also see these products inserted into conventional flash architectures, and you'll see access times drop from 100 microseconds to millisecond, which is kind of the range of flash today. You'll see that drop down to single-digit microseconds. Still much slower than memory, but much, much faster than any previous persistent memory. And the third wave is going to be persistent memory-aware software and the disappearance of storage as a separate tier. And that's probably a couple of decades worth of transition. And as a backdrop, we've seen a lot of press coverage about Moore's Law, the end of Moore's Law. I don't believe it. We've got a clear path to at least 2 more generations of process technology. But I think people will start getting intelligent about using it, and we'll see more specialized architectural accelerators as opposed to merely more cores on chips. And one final thought, it's just started. As we expand out into the Internet of Things era, a decade from now, we'll look back at the kind of numbers we're dealing with today and think, boy, they had it easy back then. They didn't know what the size of that train coming down the tracks was. So that's really kind of my final thought, is that it has just begun. And with that, I'm going to pass you over to George from Pivot 3 to expand a little bit more on how they're approaching this.
Great. Thanks a lot, Rich. That was a very comprehensive overview in a very short period of time, and is definitely very insightful. So my name is George Wagner. I'm a Senior Product Marketing Manager with Pivot3. As Stacy mentioned, I have an IT background. I was a geek for a long, long time, so this type of discussion really excites me. And I also, I speak about technology from that perspective, not just as a person who enjoys technology, but also, making sure that it's, as Rich said, strategic, right, and able to solve real problems. And I believe that's what we do here at Pivot3. We've been around since 2002. We've been designing. We've got a huge, very deep storage expertise, and we deliver smarter infrastructure in both hyper-converged, which I believe we will talk about a little bit in this discussion, but as well as flash storage solutions. And what really differentiates them and makes them smarter and more strategic is that we understand that with flash, you need to be more efficient. Okay, so we'll talk about it in a second, but Rich had mentioned the proliferation of flash. There's different form factors, different endurance levels, etc. It's incumbent upon vendors to ensure that they use the right flash for the right purpose and incorporate software to make it more efficient, such as quality of service. In the case of a hyper-converged system, employing technologies like erasure coding to provide efficiency and availability, and that's what we're able to do. Also, as we'll go through this, we'll talk through what our storage solutions are able to deliver, and let's take a look at. My mouse is being a little goofy. So we'll take a look at the flash storage considerations. I won't go too deep into them because Rich did an excellent job at covering them a few moments ago. But as he mentioned, there is a proliferation of flash. For most of us, we really think of in our mind's eye flash as being a disk drive with dandy chips in them, looks just like a hard drive, and that's just not the case. As he mentioned, it's been around for quite a long time. There are different connectivity methods, such as SAS and SATA, which are being used today, which are not very efficient, but do provide much more performance than disk. PCIe Flash, which we'll talk about in a moment, NVMe, etc., and they have different capacities. They're not just being used, as he mentioned, for this Tier 1 performance. You're going to see them more and more being relegated to Tier 2, second-tier capacities as well. So, as I mentioned, it's really incumbent. It's a responsibility of providers, of vendors, to think of this as they design their systems. It's not just putting SSD into an array and plugging it in and getting going. You need to utilize that very efficiently. Another reason why that has to be managed is that bottlenecks still exist. Okay, Flash is not a panacea, right? It's not the end-all, be-all. It's very exciting right now because it's just beginning for many folks, but bottlenecks still exist in flash arrays. Okay, I hate to burst everyone's bubble. Bottlenecks still exist. It may not be at the NAND level, but it happens in the packaging, right? The array, CPU. If you think about deduping compression algorithms, SAS controllers, etc. So bottlenecks are still injected into the system, and so it really need to, as storage vendors, as solution providers, find a way to manage that latency so it doesn't affect our most mission-critical workloads. So what we've designed at Pivot3 are multi-tier flash solutions that are both hybrid and all flash. They are multi-tier in nature, and I'll go more into that in a minute, but it really allows us to port newer flash technologies, newer storage medium in general, very easily, and it's designed to deliver predictable performance to applications. I would say, to be more specific, it guarantees performance priorities to your mission-critical workloads. Very simple to manage. So if you think about flash today, flash arrays, usually think of it as just for our mission-critical workloads, right? Tier 1, our databases, our CRM, financial databases, order databases, etc. what we're starting to see is with the ability to manage performance and provide different types of flash and including disk and managing all of that, orchestrating the performance, we allow customers to consolidate storage intelligently. I would say majority of our customers, if not almost all of them, are running some sort of virtualization, whether it's server virtualization and consolidating and getting all of their, increasing their density of server virtualization, as well as being able to host virtual desktops in those same types of environments alongside other workloads, and then applying quality of service, which I'll get into in a moment, to manage those. Meeting application SLAs is very important to us, and I'll explain how we do that in just a moment. But the bottom line is it's very simple to manage. It can be managed through various methods, which we'll get into as well. The architecture, I don't want to get too heady, too deep into the technology, but suffice it to say, this is a true multi-tier architecture designed from the ground up to accommodate really any storage media. Today, we accommodate PCIe Flash. In fact, we were the first hybrid storage vendor back in 2011 to deliver PCIe-based hybrids, and that combined, a RAM tier, PCIe Flash tier, and disk. Today, we offer both all flash as well as hybrid options, incorporating this multi-tier design for different purposes, and then orchestrating, as I mentioned, with the quality of service. They're flexible, as I mentioned, so it's all flash. It's a scale-up architecture. Dual controllers, active-active for high availability. Scalable online, so you can add shells of SSDs or disks to the system depending on the type of system that it is. It is an iSCSI SAN, so 10 gig, a lot of throughput in IOPS as well. Rich mentioned that's extremely important, and it's what customers expect in their flash arrays and their flash storage solutions. So we can get upwards of 450,000 IOPS, as well as upwards of 6 gigabytes of throughput out of our all flash arrays, and do it in a consistent manner. But bottom line is you can consolidate these mixed application workloads because we employ a sophisticated quality of service engine. All right, we designed these offerings from the ground up around quality of service. Right? Architecturally, we wanted to have a very flexible solution from a hardware standpoint, and be able to put in these newer flash architectures as they emerge and become more affordable and more commoditized. But more importantly, we knew that if we had multiple types storage media in the box, we had to be able to understand and move data real time between those. And that's what we've done with our quality of service. For those of you who are not familiar with quality of service in terms of storage, how it relates to storage, I'm sure many of you have heard it on the networking side. But on the storage side, it's really there to provide consistent levels of performance to applications. Now, what differentiates ours is that in traditional storage quality of service, you normally see only quotas, if you will, maximums. So you can set a maximum level of performance on a volume or virtual machine, and it sets a max performance level for it. It won't go past that. Well, that's fine, but what if you have available bandwidth? What if you have available performance that can be used for those applications, for those VMs? Well, it can't be used. It's locked out. So we designed ours differently. What we've done is we've employed targets. So we set these targets, simple policies, 5 policies to be exact, that manage the IOPS throughput and latency minimums. I should say maximums for latency, but minimum IOPS, minimum throughput, maximum latency for these individual storage objects. They're pre-configured, very simple. Secondly, we employ service levels. You've heard of SLAs. Okay, so SLA means you have this, whether it's implied or not implied, you have these levels of service that applications require that customers need. We can deliver those. We can ensure that certain workloads are prioritized over others and that resources get to them. And I'll show you an example of that in just a moment. And finally, real-time data placement. Rich had talked about customers of his who have multiple tiers of storage. Typically, those are seen as islands of storage or silos that you have different workloads, different that have different criticalities running on different silos. So maybe all flash, disk, hybrid, tape, et cetera. So what we do is we have all this in a box, not tape, of course, but PCIe Flash SSD, RAM is a tier, all of that into a single box, and we can move data real time between these different medium, depending on what that QoS policy needs, and in order to meet those service levels. So this is how it looks. Typically, without storage quality of service, those of you who are familiar with storage, maybe have administered in the past, it's a single pool of resources, right? It's a single pool, and it's finite, and everything's treated the same. In this case, if I have an order database, power users, and a test and dev database, while they do have their performance requirements, as you can see there, according to the storage system, they're all treated the same. So without storage quality of service, if I do have a spike in performance on that non-critical resource, it'll impact my business-critical and mission-critical workloads, and that's a problem. It leads to inconsistent performance, and at the end of the day, we as IT administrators, managers, CIOs, CTOs, what have you, it's best if you never get phone calls from people. Right? If people don't talk to you, you're the silent hero, and everything's great, hunky-dory. At Pivot 3, what we've done with our storage quality of service is we align those policies with business needs. We categorize each of those policies, each of our QoS policies, we align them with service levels. So mission critical, business critical, and non-critical. And I think you could probably understand what those mean. And let's say that if I had that same workload spike, the non-critical workload spike, we'll let it spike, we'll let it grow to a certain level, we'll give it that performance it needs to a certain point. At that point, we'll go ahead and automatically throttle it back a little bit to ensure that the SLAs can be met for our order and power user data, or our order and power user workloads. Just the same, let's say the order database needs more resources. Well, in a traditional array, that would be a problem, especially if it just doesn't have access to those. There's going to be some resource contention, not in the Pivot 3 storage QoS model. Order database needs performance, it gets performance, it gets resource priority, and we'll go ahead and throttle down the lower level workloads and to ensure that happens. And that's how we guarantee that mission critical performance is always met. Very simple to manage, of course. We have, here's a screenshot of our UI. Really just to call out that, it's very simple. It's a policy, it's predefined. In this case, we set our minimum performance targets. So every volume in that policy associated with policy 1 gets a minimum, as a group, they get a minimum 100,000 IOPS, minimum 750 megabyte per second throughput, and then and latency is somewhere around 5 milliseconds. And just saying that, it made me think about a few minutes earlier. I was going through the specs of the system, and I might have said 6 megabyte throughput. What I meant to say was 6 gigabyte throughput. If I did say that, I apologize. That way I just misspoke severely. So anyhow, these are the policy details. And then if I want to change a policy, it happens online. It happens real time. Right? They don't have to change policies. It don't have to take place overnight. This is not a tiering system, right? We do have an auto-tiering capability, but it's not tiering. Okay? So real-time data moves, does not impact performance. You can do that. It happens at any time. You can change policies at any time. And we're talking mostly about storage, and I know I don't want to take up too much of your time, but I hope you leave here with an understanding of what the Pivot 3 PCIe storage arrays are able to deliver from a capability standpoint. But I think it's also important to kind of circle around. Rich was talking about software-defined data centers and this intelligence and storage virtualization, et cetera. We do have those solutions as well, and they are truly differentiated. We do have hyper-converged systems. So what we do is we have the idea here, if you're not familiar with hyper-convergence, is for some customers who have workloads that can be self-contained, high-impact workloads, they can take and create a cluster of x86 servers, for example, that are running this hyperconvergence OS that allows you to create and create a cluster, let's say, and provision storage as well as compute, all from a single box without having to connect to SANs, right? So aggregated resource. With 3, we do have a unique approach to this. Right? We do have this modular building block architecture. We have a scale-out architecture that allows us to take and cluster multiple HCI nodes together to create a resource pool that scales in not only not only in capacity but also in performance. Shared resources, shared memory. We have a feature we call global memory that allows us to take our global cache that allows us to take a memory and extend it across all the nodes in this cluster. Scale everything. Very very simple and easy to operate as well. So, and it's optimized for, and this is very important, it's optimized for load, stress, and degraded mode operations. If you think about that, that's very similar to what I talked about with our QoS in the storage side. This is a theme in our features, in that we not only want to deliver high availability, but we also want to deliver performance as well during those instances where you may be running in a degraded state. Take the storage solution, for example. If I were to lose a controller or a disk on our storage products, we'll ensure even in a single controller we lose a single controller, we're able to deliver and meet those SLAs for mission critical workloads. Period. Right? So that's running half a system. You can still hit your SLAs on the mission critical workloads, which is fantastic. For our hyperconverged systems, not only do we run obviously excellent in a sunny day scenario, but if you were to lose, we have erasure coding, patented erasure coding. If we were to lose a node or lose multiple drives, we're still running at maybe 87% of our original operating with excellent capacity utilization, even when running in a degraded state, ensuring that not only are you online, data's online, but you're running at a pretty respectable clip as well, and those phone calls are greatly reduced, if not non-existent. And finally, to kind of wrap up what we're doing from interoperability standpoint, one of the concerns with hyperconvergence that many customers kind of scare them into where they don't want to consider hyperconvergence is that typically it's a silo within the silo. What I mean by that is they put those into their data centers alongside the traditional architecture, and their VMs can't connect to the VMs and the HCI can't connect to external storage, so they're kind of relegated to only that storage is on the HCI system, which can be a problem. In the case of Pivot 3, we are very interoperable. Okay? You're able to connect those VMs that are in our hyperconverged solution into data volumes, whether it be on a Pivot 3 storage array or into your existing environment. So if you connect a VM from your HCI systems onto a volume that's hosted by our storage, you can take advantage of the quality of service as well, which is, I would say, it's very important that when considering hyperconvergence, you consider whether or not that solution can interoperate with your existing infrastructure. From a storage perspective, to kind of wrap things up, as I mentioned, we do offer two different types of flash storage arrays. One of them is hybrid, and one of them is all flash. In the case of the hybrids, we typically are solving customers' needs that have under 10 terabytes of active data, and talking about millisecond response time. So when I say active data, I mean any data that you have in your 30, 40, 50, 60 terabytes, 100, 200 terabytes. If tens of terabytes of that are active at any given moment that need flash storage, it's perfect for that. And the purpose behind storage quality of service there is to manage that limited amount of flash that you have. And on our all-flash array, it's for 10 terabytes of active data or more, millisecond response times. And of course, going back to the beginning of our conversation, storage QoS is able to manage system bottlenecks, right? Because bottlenecks are inherent in all flash arrays, regardless of what anyone might say. So, with that, I will hand things back over to Stacy, but I want to thank you for taking time to listen. I hope you came away with a better understanding of what we're able to deliver here at Pivot 3.
Thanks so much, George and Rich. That was a fantastic presentation, and it looks like we do have a lot of interest from the audience. So we'll take these last few minutes for questions and answers. If you do have any questions for today's speakers, please just type them into the window on the side of your screen, and we'll do our best to get through them in the time remaining. So our first question is actually for Rich, and the question was asked, what workloads are best suited for flash storage?
That's an interesting question. A couple of years ago, I would have said only the most performance critical. Now it's a really wide range of workloads, from the really latency sensitive critical transactions down through mid-range file block and object storage. So it's, and especially if you have flash storage with configurable QoS, you can then handle a wide range of workloads on the same set of resources. So at this point, probably the only workloads that really aren't a consideration are data that you know you're not going to need to touch very often, where you really want to deep archive or store it, and you might want to access it but not very often, and performance requirements are slower. So you can, that's a case for disk-based storage, which is still going to be cheaper per gigabyte, but it'll have its own OpEx burden. But it's becoming increasingly hard to find a workload that's not suitable for flash now, as opposed to asking which ones. There's considerable variation. As George pointed out, there's a lot of variation in flash product landscape, and there are products on the market whose latency is 80 to 100 microseconds, which is basically at the flash device level at that point, to things in the in the millisecond range that are just like good mid-range storage. So you've got a wide range of choice. I'm sort of waffling a bit because it's really hard to come up with workloads that are ill-suited for flash now.
No, that's perfect. Thank you. And also, you mentioned Internet of Things earlier in your presentation. Can you expand on how the Internet of Things will influence the future of storage?
Yeah, it's going to generate some unknown but huge multiple of the amount of data we have today. In a nutshell, it's going to, everything we touch or do is going to potentially generate data. I mean, one of the sort of highly studied use cases is, for example, retail. Today, you walk into a store, maybe there are some beacons that will give you location-based ads, but you expand that to include sensors, location sensors, ambient light, adjusting the ambient lighting, tracking the people, making location-based promotional efforts, better communications between employees, instantaneous linkage to inventory databases, point of sale customized suggestions, point of presence customer profitability analysis. Everything is going to be, all of that data is going to be forwarded, is going to be stored, processed, aggregated, analytics applied to it. It's all got to live somewhere while that process is going on, and the momentum is toward not throwing stuff away. So there's no plausible scenario that doesn't have the next decade of IoT implementation expanding on any previous forecast by at least a couple of decimal orders of magnitude.
Great, thank you for that. George, this next one is for you. And someone has asked, what options are available for managing the storage solution?
Yes, that's a great question. We do have, as I showed a screenshot of it, we do have a web GUI, very comprehensive. That's where you can provision all of your, all of the storage policies, etc. We also have very deep integration with VMware. So if you're using vCenter, we do have plugins for vCenter, VAI. vVols is actually something where we have probably the deepest integration from a QoS standpoint than any other vendor out there. So everything I showed you on the QoS and capabilities, we've split all of that into vCenter. So you can assign those policies directly to virtual machines and vVols as well. We also have CLI APIs for Linux and Windows as well.
Fantastic. Another question for you, George, was do you plan on supporting any other Flash media types in the near future?
Yeah, no, that's a great question. I guess I did say we were multi-tier and we support different types of different Flash. So yes, in fact we are. We've got today we have PCIe Flash. I didn't get into the meat of what that means. Essentially, it's plugging Flash directly into the PCIe bus and bypassing the SAS controller that many of the SSDs are plugged into. So treating it more like memory than disk. What we'll be doing later this year is we'll be implementing NVMe, Non-Volatile Memory Express, which is a host controller interface standard for Flash. And it essentially just means that we'll be talking Flash, right? You'll be sending Flash commands, commands for reading off of Flash to the devices versus talking to them like they're disks and doing seek commands, etc. So look for NVMe probably in the near term as the next media will support.
Okay. Rich, someone has asked what you see as the barriers to adopting Flash storage.
Barriers to adopting Flash storage. There's always a little bit of there's always a little bit of enterprise conservatism. Depending on the data volume, it's still more expensive than cheap disk. Changes in process, changes in internal organization and process. If you put Flash in and treat it just like disk, you won't get the full advantage of it. But increasingly, again, fewer barriers than there were, primarily because that cost delta is narrowing rapidly.
Perfect. Thank you for that. Another question for you, Rich. You've studied this industry for many years. What do you see as the most exciting trends moving forward?
I will stand by what was in the presentation in terms of exciting trends. The intersection of flash storage and software-defined storage. That's going to have a huge impact on how people provision and manage the storage. And I think that the upcoming a few more turns of the crank and Flash will be Flash will be down at parity with all but the cheapest disks, and then it's going to become increasingly difficult to even think about anything else. The eventual coming on the scene of next generation of non-volatile memory technology is going to push things to the point where a decade from now, the default storage, new storage will be overwhelmingly Flash, and we'll start to see products we'll start to see software environments that don't have any recognizable storage tier. It's just part of the persistent part of the address space.
Perfect. Thank you. There were a couple more questions asked, but they're very case specific, so we're going to go ahead and address those after the webinar. We'll reach out to you today or tomorrow as soon as we can. If you have any other questions that you think of after this event, feel free to contact George or Rich directly. Their contact information is listed in the slide deck that we're going to send out to you guys via email. You can also email us at dg@pivot3.com, and we'll be happy to answer any questions you have. If you want to learn any more about today's topic and other upcoming webinars, you can visit us at pivot3.com. Thanks again for joining us today, and have a wonderful day.
Thank you.
Thank you.